Section 8, question 3. OA, B, C, D, F, G is a cube with side 2 units. B has the coordinates 2 to 0. P is the centre of the face OCGD. And Q is the centre of the face CBFG, which is the face at the back there. Write down the coordinates of G. Remember, for 3D coordinates, the x coordinate is going along the way, the y coordinate is your sense of depth, and the z coordinate is up and down. So for the coordinates of G, we can see that from the origin we don't need to move along at all to get to G. So it's definitely got an x coordinate of 0. We can also see that G is at the back of the shape. So it's sitting right at the back, as far back as B. The y coordinate of B is 2, which means the y coordinate of G must also be 2. The cube is 2 units long, so its height is 2. So G is on the top of the cube, so that's 2 units up from its base, therefore the z coordinate must also be 2, 0, 2, 2. Part B says find P and Q, the position vectors of points P and Q. Well, for P, again we can see that P is 0 along. Its y coordinate, well, we can see that it's halfway into the back of the shape. So its y coordinate, its depth is 1, and it's halfway up, so that's 0, 1, 1. For Q, so again that's in the middle, so it's halfway along, which is going to be 1. Q is at the back of the shape, so that's 2 in, so that's 1, 2, and it's halfway up, so that's 1, 2, 1. Part C says find the size of the angle POQ, so cos POQ is going to be equal to OP dot OQ over magnitude of OP times the magnitude of OQ. So for OP dot OQ, we'll do the scalar product. So 0 times 1 is 0, plus 1 times 2 is 2, plus 1 times 1, so that's 3. For the magnitudes, for the magnitude of QP, that's square root of 0 squared plus 1 squared plus 1 squared. So that's square root of 2. For the magnitude of OQ, that's square root of 1 squared plus 2 squared plus 1 squared, and that's equal to the square root of 6. So I've now got cos POQ is equal to 3 over root 12. So the angle POQ is going to be equal to cos inverse 3 over root 12. And that will give me 30 degrees. That's the final answer. Section 8, question 4. Vectors P and Q are such that the magnitude of P is 3, magnitude of force Q is 4. P dot Q is equal to 10. Find the value of Q dot P plus Q. Well, that's Q dot P plus Q dot Q. P dot Q is equal to Q dot P, therefore Q dot P is equal to 10. And for Q dot Q, that's just equal to the magnitude of Q squared. Magnitude of Q is 4. So that's 16, so it's 10 plus 16, the final answer is 26. Section 8, question 5. Vectors u and v are defined by u equals 3i plus 2j and v equals 2i minus 3j plus 4k. Determine whether or not u dot u and v are perpendicular to each other. If the vectors are perpendicular, then the scalar product is equal to 0, so let's just investigate that. So the components for u are 3, 2, 0. components for V are 2 minus 3, 4. So I'm just going to apply the scalar product here. So that'll be 3 times 2 plus 2 times minus 3 plus 0 times 4. So that's 6 minus 6 plus 0, which is 0. So yes, they are, since u dot v equals 0. Section 8, question 6. P is the point minus 1, 2, 1, minus 1. Q is 3, 2, minus 4. Write down PQ in component form. So PQ is equal to Q minus P. And that's 3, 2, minus 4 minus 1, 2, minus 1. 3 minus 1 is 4. 2 minus 2 is 0. Minus 4 minus 1 is minus 4 plus 1, that's minus 3. That's part A. Part B, calculate the length of PQ. So it's just its magnitude. So that's the square root of 4 squared plus 0 squared plus minus 3 squared. So it's square root of 16 plus 9, square root of 25, and its magnitude is 5. Part C, find the components of a unit vector which is parallel to PQ. Well, the unit vector has got a magnitude of 1. So the unit vector, which I'm going to call T, is a fifth of the size of that vector. So that's 4 fifths, 0 minus 3 fifths.